using a spreadsheet program can be really handy. So it's a good idea to get familiar with one. This is Google Sheets. Most schools use it, and it's free with a Google account. You can also use Microsoft Excel or some other ones. So what I did is measured the time for 5 cycles. And I got 6.58 seconds to complete 5 cycles with a length of 0.45 meters. Then I repeated it, and I got a little bit different number this time, 6.63. And then I repeated it a third time, and I got 6.52. I did my test 3 times, and I averaged them, and then I divided by 5 to get the period, because I want to know the time it takes to complete one cycle. So that's how I got this number over here, the period in seconds when the length of the string, and I keep saying the length of the string, the distance between the pivot point and the center of mass of my pendulum is 0.45 meters. That's how I got this number, 1.315. Then I changed the length of my string. I made it a little bit longer, and I did this again. I'm not showing you all of that data. I'm just putting the period in here, but I wanted you to know how I got those numbers. If you're not familiar with the spreadsheet program, play around, get familiar with it. You can click on a cell and type in, this is going to be on my x-axis. This is going to be on my y-axis. You can highlight those cells and center the text and make them bold or do whatever you want. Play around. The important thing is that the numbers are correct because that's what we care about. We're going to look at the numbers here. So I'm going to select those cells by clicking on them and highlighting. And then I'm going to click Insert Chart. And it tries to guess. It's picked a scatter chart, which actually is what I always use when I do data like this. There are many different kinds of charts, but the scatter chart is a really good one when you have data points and you're trying to analyze data points. I'm going to move the graph over a little bit. And it tries to guess what the scale should be. Sometimes it gets it right, sometimes it doesn't. We can click on the scale here for the x-axis, click on any of those numbers, and it brings up this box, and we could tell it we want it to start at 0 and go to 1. And there's our data right there. We could click on the y-axis and change the scale there, but I think it looks good the way it is. Now this data looks pretty linear, doesn't it? What we want to do is fit a line to this and see what the equation is. If we double click on the chart, it brings up the chart editor, and we click Customize and then Series, and we scroll down and click this box that says trend line. We want to add a trend line. And then it says, well, what kind of trend line, what type? A linear trend line, that's just assumes this data fits a nice straight line. And it looks very good. It looks like it fits a very good straight line here, but that's because I didn't change my length of the string very much. I went from 0.45 meters up to 0.9 meters. That's not very much. If I had really changed the length, if I had hung my pendulum from the ceiling and changed the length out to 2 meters or maybe more, I would have seen that a linear fit isn't very good for this data. But because my data is kind of clumped together, you know, a linear fit looks very good. It looks like all those points fall on a nice straight line. But I'm going to cheat a little bit. I already know the answer to this problem. It's a power series, so I'm going to select power series. And actually, this is a very, very good fit too in here. And if I had strings of different lengths, this would have been more obvious that this is a better fit. But because mine are close together, it's hard to tell. So I'm going to use the power series. And of course, that is not very useful just having a line in my graph. I need the equation. I need to know what the equation of that line is. So I'm going to click Use Equation for the label. So now it's giving me an equation here. This should really be y equals 1.97 times x to the 0.489 power. So let's take a closer look at that and see what that tells us. The equation that Google Sheets gave us is y is equal to 1.97 x to the 0.489 power. This funny symbol right here is called a caret, and that means exponent. So let me rewrite this equation so it looks a little more like something you've seen. I'm just going to rewrite it here. Y is equal to 1.97 times x to the 0.489 power. Okay, so that's the equation we get from the spreadsheet, from the graph. Now we need to figure out what is y and what is x. If you remember, we plotted the period on the y-axis and the length on the x-axis. So when the equation tells us y, they don't know what we're actually plotting on the y-axis, so they just put a y there to tell us it's whatever's being plotted on the y-axis. In our case, it's the period of the pendulum. And on the x-axis, the x stands for length. We're going to compare the equation we got from our spreadsheet and graph to the actual equation from our physics textbook. In our physics textbook, it tells us the period is equal to 2 pi times the square root of the length over g. G stands for the acceleration of gravity, which is 9.8 in the units we're using here, meters and seconds. I'm going to rewrite the equation as 2 pi over the square root of g. I can pull that g out from inside the square root sign and bring it out by itself, times the square root of the length. So now I can compare these two equations. All the stuff out here in front of my x has to be the same as the stuff right here. So I can compare those two things. And x to the 0.489 power, I can compare to the length, the square root of the length, because the square root of the length is the length to the 0.5 power. So comparing those two numbers, I got the length to the 0.489 power, but the formula tells me it's the length to the 0.5 power. A square root is the same as a 0.5 power. So those are very close. Not bad for a quick measurement using a bag of quarters. Now let's look at the other number. Comparing 1.97 to 2 pi over the square root of g, I get very close results again. And for a 2 pi over the square root of g, remember g is 9.8, so I get 2.007. So 1.97 was given to me by the equation from the chart, and 2.007 I get from the formula in my physics textbook. Again, very close agreement. Not bad for this experiment. I know this is a little heavy on the math, but I hope you enjoyed using the spreadsheet, and I hope you got a little bit of the flavor for how powerful spreadsheets can be in helping us analyze data.